services. So this I divide into two parts. Is the first part I will do like introduce a basic concept of 12-factor app in why and how and what fashion, and the second part I will do live coding, basically creating 12-factor microservices from scratch using MicroProfile. So let's get started. So 12 factors, if you have not heard of the 12 factor, basically it's a methodology, the best practice manifesto for building cloud native microservices. It's published by Heroku, so it's in the 12factor.net. So you can check it out if you have not heard of it. So why do we care about this 12 factor? So it's basically 12 factors came from the reasoning. Basically, we don't want to trap on each other's toes between the application and the infrastructure. So we want to define the kind of clear contract. Which bit need to be handled by application, which bit need to be handled by infrastructure. So this is a long version of the 12 factor. So basically, it's at the moment we are living in the software as a service era. So it's a 12 factor methodology for building this software as a service apps. So it's 12 factor app is kind of use the declarative format. So is everybody when you define the 12 factor app, you know, so what need to be in this application. So what kind of capabilities this application need to bear, and has a defined very clean contract between this application and infrastructure, like the cloud infrastructure and etc. So once you comply with the 12-factor app, and your application is very easy to be deployed into the cloud infrastructure, and also is able to scale up and down without much change. And also it's kind of minimize the divergence between development and production. Basically, you won't run into the problem like it works on my machine and it works in the development and stopped working in the production, and etc. One thing I want to bring it up is 12-factor app is kind of language agnostic. So you can write a 12-factor app using different languages. However, in this talk, we focus on Java. So this 12-factor called 12-factor app is because it has 12 factors from code base, dependencies, config, etc. into the admin processes. In this first part, I will describe each factor, so give you a quick overview about what it's about for per factor, and then tell you how to implement this factor as well. So how to build a 12-factor app? So it's I have talked this, I have done this talk before. Why asked who knows the 12-factor app? A lot of people actually have heard of the 12-factor app. And then I asked who has built one, and not many hands up. Actually, even if you haven't built one, hopefully in this session you will realize that you already implemented some factor of this 12-factor app. So hopefully this talk will make your microservices and fulfill more factors in this 12-factor app. So it's how to build one. Actually, Eclipse, MicroProfile, and Kubernetes can help you to build a 12-factor app. So if you have not heard of MicroProfile is under Eclipse Foundation. So it's quite a few speakers. I think he's all mentioned the Eclipse MicroProfile, and it's very popular. It's community driven, and it's the Spec API TCK freely available in the public domain, and it has very lightweight iterative process. So this is a community, has kind of over a dozen vendors like including IBM, Red Hat, Parity, Tommy Tribe, London Java community, and also is Oracle and Microsoft together with others. Today I checked, there's about 178 individual contributors, and it's still growing. I can see it's growing like every month. It picked up more contributors, which is very healthy. So this is kind of community like heading towards the right direction, because it's attracting a lot of attention, which is great. Also, there's about dozen independent implementations. So here, like I know admin being mentioned, like Open Liberty, Quarkus, Wildfly, and also Halliday, Parity, Tommy, and also Fujitsu has Apache Launcher, and Kubernetes EE, Hammock, and Prana. They all adopt MicroProfile, which is great. And I mentioned earlier, MicroProfile has very rapid iterative process. Every year we have 3 releases per year. At the moment, the latest release is MicroProfile 3.3, so which I will demo later. So in the next few minutes, I try to quickly go through each individual factors. The first one is the code base. So it's one code base per microservice. So basically also the code base tracked in the version control system. So it's ideally is one small team manages this single code base, and this code base has a dedicated release cadence, release process as well. So it's as you all know, I think the majority of us are using GitHub. So each microservice will map to a Git repo. So this is kind of best practices. The other thing, the second factor is dependencies. You should declare your dependencies either in Maven or Gradle. So in the Paul XML, for example, in Maven, you declare what kind of dependencies you need in your application. So and then you can freely change the version, etc. Do not pre-package this dependency inside your application, because if you pre-package it and then you will have it forever, and you end up probably rely on more and more of this particular version, and you don't know, when to upgrade to the new version, etc. The third one is the config. So you should always store config in the environment. So this is enable you to build your microservice once and configure everywhere. So basically, when you develop cloud native microservices, and you will surely most of the time you will want to deploy to Kubernetes, Kubernetes, and you can use Kubernetes config map or secrets to specify your config, and then you can inject into your application. So in this way, if you change the value of the config properties, and your microservice stay unchanged, so the Java classes and etc. do not need to change. So MicroProfile config can help you to externalize the configuration. So basically, the MicroProfile has 2 APIs available to you. The first one is the programmatic lookup. You can do a config provider.get config, and then you can do the get a config object, and then you can do a get value and specify which value you want. Like myprop is the property name. Or you can use the CDI injection, which is quite popular. Quite a few speakers demonstrate how to use the CDI injection, like add config property, specify config property name, and then you can get a CDI directly inject the config value into this myprop v variable. So the next one is backing services. So treat these backing services as attached resources. In this way, my microservice, for example, is the set up code application. So you can I can attach Twitter, for example. And later on, if it's Twitter doesn't work, if it's a kind of Facebook and shares the exactly same API, I can directly swap in Facebook. So this is the kind of, if it's freely, you can configure these attached resources, and you have greater freedom to swap out the dependencies. So MicroProfile REST client direct you to help you to do this loosely coupled attachment. So basically, if service A trying to call service B, and you can directly to put the service B's API. For example, here service B API is get properties, is get operation, and produces JSON payload. And I can in service A, I can directly create this API as a register REST client, and then I can directly inject this REST client to my microservice A's JAX as resources, and I can say default REST client, and into this default REST client variable, and then default REST client, you can have this get properties method for you to call. And is service B with service A then. So it's luckily MicroProfile REST client utilize MicroProfile config. So at the bottom, this on the bottom of this slide, you can see fully qualified class name, system client, and /mprest/URL, and then you can specify the service B's endpoint. So it's 9080 system. And then when service A, when you call default REST client .get properties, it automatically go to this endpoint localhost 9080/system to invoke this service B. The fifth factor is build, release, run. So you should separate them all. So it's like a build and then release, and then it's the run stage. So basically, you can also adopt some CI pipelines such as Tekton. So it's, if you have not heard of it, check it out. So the next one is the processes. You should execute your 12-factor app as one or more stateless processes. The best practice is to use JAX as a specification to create your microservice, because that enables the stateless and share nothing. In this case, you can freely destroy any processes or scale down or scale up without losing any information. So in this slide, I compare them as a pet versus cattle. So you should treat your 12-factor app as cattle. So basically, you can freely scale up or down without losing much information. So it's pet has a personality. Even all the pets, they are different. They have their own personality, so they are not replaceable. So this is kind of use this analogy to say this your processes should be stateless like a cattle. The seventh one is port binding. So you should export your services via port binding. As you know, when in the development, in the OpenLiberty, for example, is port in 9080, or you can configure to use a different port. However, when you deploy this microservice to Kubernetes, Kubernetes will give you a different port. So in your microservice inside your Java application, you should not hard code your port. You should always be able to inject the port into your application. Again, you can use the MicroProfile config to directly inject the port. So the next one is concurrency. So this is kind of demonstrate actually without much change in your application, or without any change in your application, you can scale up or scale down without scale up or scale down, and based on the load. So is Knative has auto scaling. You should create an algorithm for the auto scaling scaling and what kind of circumstances you can scale up or down. And you can even scale down to 0 if you want. So the next one is this possibility. Basically, this need to ensure your microservice can start up and shut down and very fast. It's because every minute you live in the cloud like cost money. So you should always like start up and shut down very fast. And also you need to make sure your processes is robust. So it should be able to cope with any like kind of unexpected like situations. You should always think how can you improve your microservice resilience. So luckily, MicroProfile fault tolerance can help you to create a very resilient microservice. So it has a few annotations like retry, circuit breaker, bulkhead, timeout, and fallback. So later on, I will try to demonstrate this how to create the resilient microservice using MicroProfile. So the next one is dev product parity. So basically, you should keep the development, staging, and production as similar as possible in terms of the people and the code and the environment. So you should always think about to use operators when you deploy these containers to your cloud as well. So the next one is treat the logs as event streams. You should one of the best practices is to use the standard out to directly stream out the logs, and then you can directly feed into the ELK. So you can analyze it and etc. So the other best practices, your logs should be in the JSON format. So again, it's quite good to be analyzed by ELK. So the last one is admin processes. So you should run the admin processes as one-off processes. So it's a one-off jobs. You should consider to use kubectl exec or Kubernetes jobs. The reason is the one-off processes is once it start and then finish and terminate it. If you build in your microservices, most of the time your microservice is running all the time. So if it's only one-off, is your microservice doesn't need to be running all the time. So that's a very quick introduction of this 12 factor. You can see code base. You can use GitHub, dependencies, Maven, Gradle, config, backing services, processes, port binding, and disposability using MicroProfile, build, release, run, and dev product parity. Logs their best practices, concurrency, and admin processes. You can use Kubernetes. So it's in the quickly use this 80 minutes to to briefly introduce this 12-factor app. So how can I build one? So there's a few tools to get you started. So you can use MicroProfile Starter to create a MicroProfile application. So I demonstrate is how can you fulfill this 12-factor app. And also, if you have not heard of Upstate.dev, has a few stacks for you as well. There's a kind of Open Liberty stacks and Quarkus stack and etc. and different languages as well. And also is some other vendors. They also offer some generators for you. Let me finish these chats. Let me share my screen. So in this demo, so I create two 12-factor app. One is service A, the other service B. So I try to demonstrate they don't. This is service A and service B. They don't need to be in the install in the same application server. So in my demo, service A is running on Liberty and service B running on Quarkus. So in order to save time, my service B I already created via some start.microprofile.io. And it's very simple. So basically it's JakartaOne's application. So you can see service controller, JakartaOne controller. And its API is do something. And I on purpose put some delay and sometimes throw exception, so that I try to demonstrate how to create a resilient microservice A. So this is Quarkus. Let me create the service A from scratch. So the start.microprofile.l is a great starter to, let me make it bigger, to get you started to create a microprofile applications. So it's like I give it artifact liberty. I use the latest microprofile version is 3.3. You can see it has 3 runtime for you to choose from: Wildfire, OpenLiberty, and Cumulus EE. Let me select all of them and then download. So now is my microservice okay, so this is my actually I only want to use this service A and go to this. You can see the service A. Let me start my VS Code ID. So this is service A. So basically, it has a few endpoints. So the endpoint I'm interested is the client. Let me make it bigger. So it's basically, as I showed you earlier, the service B has the service B has the APIs to do something and take a param and get operation, and this is a get operation, and in like 12-factor app is that it's kind of how to so it's one factor is treat your dependencies as attached resources. So I mentioned the MicroProfile REST client. So basically in this demo, like I demonstrate to you how to connect microservice A with microservice B. So basically, how can I invoke a microservice B? So it's in microservice A, I directly create this API, microservice B is the API, and then I annotate register as a client. And then I can directly inject into this my JAX as resources, inject at the REST client service, and then I can directly call it. So now, let's go back here. Let me start my microservice A. Is one thing is really Sebastian mentioned earlier. If you have been to his talk, is Liberty and Quarkus have both support development mode. So which means you can code your microservice and then you can see the change straight away. So it's this is a starting Liberty in the development mode, and it's we expose the the application in the port 9080, and now this is a microservice B and live on Quarkus. So let me start Quarkus in the dev mode as well. Okay, so as I mentioned earlier, look at is all the kind of is this Quarkus is install these modules and etc. And Liberty also install some modules. Is both looks quite similar. So now, as I mentioned, my like a microservice A live on the port 9080. Now this is a REST client endpoint. So is I want to call into service B. However, I already got a service B up running. How can I make sure I can wire to service B? It's very neat from MicroProfile REST client. So here, like in the config here, like this is a fully qualified class name service, and then /mprest/URL. So I know the so this port I hard coded, I put in the config 9081. However, in Quarkus, it live on 8080. So you can see here. See, you can hear 8080. So now is let's go back here, go to the service A. So I can change here to 8080. Let's go back to the service A, localhost 9080 again. So you can see it's a Quarkus service B. So if you I want to demonstrate a bit like the Quarkus is a dev mode. So you can see here, I say this is Quarkus. I directly change that. Now I go back to the endpoint. So you can see this is Quarkus service B. So this is like while I'm coding, and you can see the changes straight away. So the next thing is I want to demonstrate the third factor, which is externalize your configuration. So in service A here, if in the I want to like define a conference, for example, I say Jakarta Live. So and then in my application, in my JakartaOne resources, I can directly inject it. I can say inject config property and name equals conference, and then I can string conf, and then I can say we are live at I can add something else, make it nice. Let's go back here. See, you can see the changes straight away. We are live at Jakarta. So this is both the beauty of the dev mode. So now is if I click this, you can see the two applications all start really fast, right? This is the fast startup, gracefully shutdown. However, as I mentioned earlier, I on purpose and put some fault in the service B. You can see sometimes it's not working. So now I demonstrate to you how can I make the service A very resilient by using MicroProfile for tolerance. So I can say is a retry. You can see, okay, if I see sometimes it's not working, okay, I just use a retry, and then you can see it always works. However, sometimes it's still slow. So now I need to fix the slowness. So sometimes you cannot access the backend, so you have to do something yourself in the coding service. So I can use I can say, okay, I don't have time to waste. I want to say timeout. I have 100 milliseconds. So when I use the timeout is always important to use asynchronous to make sure it's happening in a separate thread. So in this case, I need to return a completion stage. So it will be Java YouTube, and then completable future, and then I can say completed future. We import this one. Okay, let me save it. Now I can go back. So you can see here, you don't see any delays. You can see some delays, but that is 100 milliseconds. Basically, you get timeout exception and directly retry. So the other best practice is always try to use the fallback. So this is very important, especially in the cloud infrastructure. In the cloud, basically, you have sometimes you are auto control about things might go wrong. So it's always very good. It's always important to provide fallback services. For example, here I provide this different fallback, so I can say this is my fallback. Alternatively, you might want to call into a different service. Maybe this is all. You fall back to a cache. Okay, so this is the kind of I demonstrate to you like how to create the resilience microservices using MicroProfile for tolerance. So it's in this way. We quickly go here. So I demonstrate the config. So using MicroProfile config, and the backing services are using MicroProfile REST client. And then process demo in a minute. This possibility, so I demonstrate the fault tolerance aspect. And also I use very lightweight application server, so can start very fast. So now, I'm happy with my microservices and etc. So I'm happy with it. So it's the next step will be containerize this microservice. So this is okay because this is purpose and build this fault. Now I can stop this microservice, and then I can do a Maven verify, build this. So I can stop that. Similarly, I can do a Quarkus build. So it's all very fast. And now I can I will copy my this is my service A. I copy the Docker file, and then I can build this Docker image. So you can build a Docker image, and then while it's building, quickly show you what this Docker file is like. So this is the Quarkus Docker files, basically from this Fabric 8. So it's very only a few lines, and this is the OpenLiberty Docker file directly from OpenLiberty kernel, and then you copy a few server config and run config.sh. This next thing is running that. So next thing I want to copy the Kubernetes deployment file. So basically, the in today's session, I know it's Sebastian demonstrates on the IBM Cloud, and Adam Ben demonstrates deploy to OpenShift. So for me, I have my own Docker desktop. So I have a native Kubernetes. So I can directly deploy my 2 microservices to my local desktop. So it's with Kubernetes running. So directly show this one. So this is my deployment YAML file. So let me quickly show you this deployment. So basically, is in my demo, I have 2 microservices, service A and also service B, and I did a Docker build for service A. So it's the tag is Liberty Service A and :10. So this is my Docker image, and the container port in 9080. So one thing I really want to show is this one. So basically, it's in my microservice in here, I provide the backend is localhost 8080. However, when I deploy it to the Kubernetes, that host and port both changes. So here is a kind of, I can easily and provide a new value for that wiring. So this is a fully qualified class name for this service, and mp-res/URL. Because this is environment variable name only allowed to use alphanumeric and underscores. So it's non-illegal one / or hash or convert to be underscore. So it's instead of directly route to localhost 8080, this route to factor up B service. So you might ask, where's the factor up B service? It's because the per microservice, you need to have a deployment, and also you need to define the service. So the app B service, I give it the name is the factor app B service, and it is the HTTP port is 9080. So this is one thing. The other thing, as I mentioned earlier, in here, I said a conference Jakarta Live. But in Kubernetes, I can easily change it to be a different value, like a Jakarta Livestream 2020. So in order to save time, I already have that the 2 microservices deployed to Kubernetes. So let's quickly look. So as you can see here, I have this 2 microservices deployed. Service A has 1 replica, service B has 2 replica. I mentioned in Kubernetes, and you can easily change the how many instances you have. So here, in my native Kubernetes, I define the replicas is for example, it's 2, and later on, maybe you can use auto scaling to directly configure how many replicas you have. So it's, this is, for example, previously, currently running is replica is 1. Now actually I copied the 1 is with 2. If I do Kubernetes apply -f deployment, so you can see if I do get port, so it will start up a new one because currently it's 1, but in my Kubernetes YAML file, I said I want to, it will scale up to 2 instances of this. So it's very soon. Look, it's started up running. So it's where is the service? So if I do get services, the factor app A is a cluster IP. So it has the port 30080. So how do I know is service A is exposed port? It's because in service A, I declared as a container port. So it's service A. I declared the type in the node port, and service B is cluster IP. so it's mapped to the 30080. Let me go back here. If I go to 3, so it's here is 30080 is up running, and then you can see here is the service B and sometimes not ready, and then you can directly see the service B response. You can see here, like in my local environment, I said Jakarta live, but in my Kubernetes, like the Kubernetes, the conference value is called Jakarta Livestream 2020. So this is the externalized configuration. I don't need to change my microservice. I easily can control the config value. I mean, I can feed the config value from the config map and some other config sources and etc. So this is the quick demo I have. And then let me go back to the presentation again. So it's basically I demonstrated you can use MicroProfile and Kubernetes build like 12-factor app. So it's you clearly separate out what kind of capabilities, your what kind of quality of services your microservice should have, and what kind of quality of services or the capabilities your cloud infrastructure should provide, so that it is really nicely their responsibilities etc. really nicely separated out, so they don't step into each other's toes. So again, this is a quick recap, like code base, GitHub, dependencies, Maven, Gradle, configure backend service and processes, and port binding and disposability, MicroProfile. Concurrency are also demonstrate how can you use replicas to scale up or scale down, and also dev product parity logs, build processes, and etc. is best practices. If you have admin processing, you can use Kubernetes jobs. So this is kind of good references for you to look up any more things you are interested in. So this demo is on my personal GitHub, is vsummit-12-factor app A, so check it out. So as you can see, I also demonstrate per microservices per GitHub repo, so it's app A. They are all properly version controlled. And even in the deployment YAML file, they also need to be version controlled as well. So it's checked into a separate GitHub repo. So that's the end of this presentation. So follow me on Twitter if you want to get to know more about Liberty and MicroProfile and Jakarta information, etc. Are there any questions?
So there weren't any. Oh, there was one question actually. So I'll read that out here. It's from Sergey. What do you think about the latest trend that combines together development and DevOps practices? I mean, should developers take care about deployment stuff, or would it be better to keep single responsibility principle here as well?
Yeah, it's a great question. Yes, I think it's now is way into the microservice world, and developers, actually single team should manage development, also manage the DevOps. So again, is I think it's more and more people realize that cloud native is not about containers, it's about culture. I think Holly Cummings is kind of a big phrase for this. So it's good if in your company you have a separate team, however, that they should interlock with each other. Developers should know, what kind of deployment environment, and also the tooling it uses, and they should work in a team, even though sometimes maybe different people. but they should have a Scrum together and then know each other's kind of responsibility and know each other's jobs quite well. So you can easily even do the development, or one day you can go to the DevOps to operate your microservices in production.
That's great. Thank you so much, Emily. I think we're going to wrap up here and we will get ready for the next session. But thanks again for presenting. That was great.
Thank you. Thank you, Christine. Thank you, everybody, for joining in. Bye.
Bye.